Hello, and welcome to the lesson today on selecting and interpreting graphs. So we're going to be looking at graphs such as circle graphs, histograms, line graphs, box and whisker, stem and leaf graphs, all of those ones that we use to represent data. And so we're going to be working in topics under the standards 3.1a and 3.1b, and also the study island topic, select and interpret graphs. So if you're working in any of those places, this is where you want to be to get a little extra lesson. And we're going to be, those graphs that I mentioned, we're going to be reading them and matching them to data and just IDing which one's the best one to use in different cases. So as we are about to start that, remember our study tips. You can pause and rewind and fast forward you any need to. So when you're taking your notes, if I go too fast, just press pause. And when you get caught back up, just join us again. And then also you can pause at the beginning of an example, see what you think the answer is, and then press play and see how well you did. So I'm so glad that you're here and taking the time to learn a little bit more. So the first thing let's go ahead and take some notes, and then we'll get started on some examples.
There are 6 types of graphs that these questions are going to ask you to pick and interpret. So the first one is a line graph. And you can see that's just when you plot points, data points, and then connect the dots. So that's different than a line of best fit. This is the one where you actually connect the dots. And this is best used for to show change over time. So if you notice this, the x-axis here is time in seconds. So lots of times one of your axes will be an increment of time. So the next one is a bar graph. And that's just when you have, Monday, that's about 82. You have the different bars to show you for different categories. And this type is best used for comparing categorical data. Categorical meaning not numbers. So look, you were comparing Monday, Tuesday, Wednesday, Thursday, Friday. Those are categories, days of the week. They're something you can't measure with a number. So a historygram is a special type of bar graph. It's one where you are measuring increments. So here, if we look at the bottom, there's about this is final scores. So if somebody scored a 1, then there was one student that scored in the 20s to the 30s. So then the test score from 30 to 40, there was 2 students that scored that. From 40 to 50, there was 1 student that scored that. So it's a range of scores that you're looking at here. And that is what it's best used for, is comparing frequencies of numerical data that fall in equal intervals. So a test score, that's a number, that's numerical data. The next one is a circle graph, and that's best used for comparing categorical data as parts of a whole, so in percent. So that's why when you see a circle graph, there's always a percent, so that you can see here very easily how many people favorite pizza topping is pepperoni versus cheese, sausage, and supreme. It makes a nice picture, but it always has percents. Stem and leaf plot. Most stem and leaf plots should have a key. Now, Study Island doesn't always give us a key, so you assume that it's the tens column here and the ones column here. But here, this would be, they divide numbers up, and the reason they do that is because it's ideal for range and frequency. So you can see, well, how many numbers are in the 30s pretty easily. How many ages here are in the 20s? How many are below 10? You can see that pretty easily. In this one, it keeps all the original data points, which is also nice. And then our last one here is a box and whisker plot. And a box and whisker plot, you always have 5 numbers, but you lose all the rest. So you get the middle quartile, which is the median of all the data, You get the lower quartile, which is the median of the bottom half of the data, the upper quartile, which is the median of the upper half, and then the lower and upper extreme, which is the smallest and largest number of the data set. So the only two numbers you know for sure are actually in your original data set are the beginning and the end. So this just helps you to see how the data is distributed into the 4 parts. And it's best used for that organization into 4 groups about equal size, and they're nice if you need to often identify the median. So in this example, they give us a line graph. It says Sally went on a road trip. She arrived at her destination 10 hours later. The graph below shows her progress. If Sally's trip from Chicago to Nashville started at 4:14 a.m. and went through Indianapolis, what time did Sally get to Indianapolis if Indianapolis is 200 miles away from Chicago? So if we look at this graph, it shows us every hour how many total miles she's traveled. So if she's saying from Indianapolis to Chicago is the first 200 miles of her trip. So if I go up here to 200 miles and come over, that's not an actual data point, but it's like right before 4 hours. So it's between 3 and 4, but closer to 4. So if she started at 4:14 a.m., if I add 4 hours to that, that's going to be 8:14 a.m. But it's actually going to be a little bit before that. So if I go over here and look at the choices that I may have, well, A doesn't make sense. That's way too before. B, that's an hour before. I know that it's just right before 4 there. So it's definitely after 3 hours. So it's not going to be B. C, that's way too early. And D, that's 15 minutes before. That makes sense. So my answer here is going to be D. This example here gives us bar graph and circle graphs. It says Greg interviewed all 50 people in the 8th grade at his school and asked them what their favorite sport was. He placed the results in a bar graph below. He then decided to put the information into a pie graph instead. What graph below fits the data in his bar graph? So which one of these is the same set of data? Well, if I look here, volleyball is at 25. Okay, I have 25 people in volleyball. Out of the 50 total that it tells us are in 5th grade, 25 out of 50, that reduces to 1/2. That's going to be the same as 50%. And you can even see that volleyball is the largest bar. So that means down here in our circle graphs, we need the yellow, the volleyball, to be the largest amount. So it's definitely not the largest amount in X because 30 is bigger than 25. In Z, 50 is bigger than 30. Now in W, 35 is the biggest percent and 50 is the biggest percent. But like I said, 25 over 50, that's going to become 1/2. 1 divided by 2, or even 25 divided by 50 is 0.50. And when you times that by 100 to convert it to a percent, you get 50%. And you might have been able to see that straight from 25 out of 50, but that's where I got the 50%. And that's what it is in Y. So my answer here is Y, which is letter B. Here's another example with circle graphs. It says Logan wants to graph the percent of students in his grade who has at least one brother. He surveyed 100 of his classmates and found that 80 students have at least one brother and 20 do not have any. Which of the graph below matches Logan's data? Well, this one's kind of exciting because all percents are out of 100. So he found that 80 students have a brother, at least one, and 20 out of 100 don't have any. So that means that 80% have a brother and 20% have none. And because that's out of 100, I can do that quick. If it was any number but 100, I'd have to convert it to a percent. But here I have 80 and 20, and the one that shows me that is X, so my answer is C. Now we have to pick the graph that is the most useful in this situation. So that's when those notes I gave you in the very beginning with the 6 types of graphs and when they're best used for, that's why those notes are important. So hopefully you copied them down so you can be looking at them as we go over these questions. All right, this example says, which graph type would be best suited for showing the median amount of profits for all the shop marts in the United States? We have A, box and whisker plot, B, scatter plot, C, line graph, and D, pie graph. So this question is asking, it wants to know about a median. Well, anytime we're talking about a median, we want to go straight for the box and whisker plot because it has the median, the lower median, and the upper median. So anytime it's asking about median, your answer is going to be box and whisker plot. This example says, which graph type is best suited for displaying the total shoe sales of a shoe store for each month? Well, okay, it wants to display it for each month. Month is a category type data. January, February, March, April. That's not a number. It's a category. And so the only one that we have that deals with categorical data is a histogram. So that's going to be letter B as our answer. This example asks, what type of graph is best suited for displaying range and frequency distribution of a student's test score while still showing each individual test score? So this one here, it wants to know about range, frequency, and individual score. So it doesn't want to lose any of the data. So in a box and whisker plot, you lose the data. In a pie chart, you just get the percents. You lose the actual data. So here, in a histogram, it doesn't deal with numbers. It deals with categories. So that leaves us with the stem and leaf plot. And remember back to our notes, stem and leaf plot is ideal for range and frequency. This example says, Grace took a poll of everyone's favorite school lunch. She wanted to find out what percentage of students prefer each meal. Which of the following is the best type of graph to help Grace? Well, she wants to deal with percent in her graph. The only graph here that deals with percent is the circle graph. Not the histogram, not the line graph, not the bar graph. So that's why your answer here is A. Okay, in this example, it says the following stem and leaf plot shows the range of 10 numbers. What is the lowest number in this plot? So just so you understand how a stem and leaf plot works, they should give you a key to show you how the numbers, what place value they are. But if they don't, then you assume that this leaf part over here, that's what we call the area to the right, is the ones column. And so if I were to take these numbers off of the stem and leaf plot and list them back out, that first one would be 865. So I get that from this stem and the leaf. And then I have 866. That comes from this stem and this leaf. And then I have 869. So that's the 3 numbers I get from this first row. Then my next row is 870, 873, 878, which is this row here. And then this next row is 885, and then 885 again. And then my last row is 892, and then 895. So those are the 10 numbers that they had put into this stem and leaf plot. So I wanted to show you how that works. So, and they always do them smallest to biggest. It's always in numerical order. So to get the smallest number, I would just go to the top row in that first leaf. So that's going to be 865, which is C. Here's another example of a line graph they're asking us to interpret. It says, a new video store, Videos Cheap, track the number of videos they sold for the first week and a half. Between which 2 days did the movie rental decrease the most? And this is something an actual business would do, so they could see, maybe I need to offer a special promotion on Tuesdays because I don't sell as many videos that day. And so you're looking here for which line shows the most decrease. Well, the biggest drop is going to be right here. That's our longest decreasing line from day 6 to day 7. So our answer here is going to be C. Okay, we're given a bar graph. In this example, it's actually a double bar graph because there's 2 bars for each day being compared. And it says, how many more chocolate ice cream cones were sold than vanilla on Tuesday? So we're looking at Tuesday, which are these top 2 bars. And we have chocolate as this darker color and yellow is our vanilla. So on Tuesday, if we go out to the end of the bar, 18 chocolate were sold. And then if we go out to the end of the yellow bar, the 10 vanilla were sold. So if I subtract those 2 numbers, I get 8. So that means 8 more chocolate were sold than vanilla. Thank you for joining us today, and I hope you learned something new.